Hey, g'day, it's Brezzo, and thanks for stopping by the workshop today. I'm starting on a new project, and just recently my wife and I decided that we wanted to redecorate one of the guest bedrooms in our house, and we decided to embrace the mid-century modern style. Now this was a period between say 1950 and 1970, and the furniture at this period was very low, very sleek, had a lot of straight lines, almost Scandinavian in sort of influence. And in that room I built a queen-size bed head with some integrated bedside tables and a pair of lamps that go on those bedside tables. But the other corner of the room has just two chairs and it looks a bit bare, and we decided we wanted to put a small side table between the two chairs and then put another lamp on top of that side table. Now the style of lamp that I want to use is a bit unusual, and here it is here. Now this is a lava lamp. Now these were designed back in 1963 by a gentleman named Edward Craven Walker. Now they're still being made today. There's a company called Mathmos, M-A-T-H-M-O-S. They still make the originals. This is not one of those. This is a cheap one that I bought on Amazon, and believe me, it's very cheap. But I want to upcycle it. I want to make it look a bit more like it came from that mid-century modern period, or another period called Atomic Age, which was part of that same time period. So in order to upcycle it, we need to understand how it works. So let's have a closer look at the guts of it, and that will have an influence on how we change the design. So here's a bit of a close-up look at this thing, but quite honestly it looks like something that you might buy at an adult store. And I want to make it look a bit more like a rocket. So the initial idea was to replace this bottom section of the lamp with a metal casting which would have some rocket fins and a rocket nozzle. And then I started to do some research and realised that there was a little bit more to it than that. But let's have a look at the individual parts. Now at the top of the lamp is just a spun aluminium cap. It's been powder coated. I know that because I've already rubbed off the powder coat. And it's just a decorative cap that sits on top of this glass bottle. Now the glass bottle itself has a sealed cap, which is not a screw-on cap, it's actually bonded on with some sort of a cement. And the bottle contains a water-like substance. Apparently it's not pure water, there's some other ingredient in there which is a bit of a trade secret. And then there's also a lump of coloured wax. Now you can buy these in different colours, but it's just the colour of the wax that changes the colour of the lamp. And when the lamp is cold and at rest, the wax sinks to the bottom and congeals into a solid lump. But inside this base here is a heat lamp. The heat heats the water inside the bottle, and that in turn melts the wax, and the wax gains buoyancy as it gets hot. So it wants to rise to the top of the bottle, and it cools in that position and then starts to sink back down to the bottom, and the cycle just repeats itself. Now, word of caution, don't shake one of these things while it's hot. The wax lumps will break up into very small droplets. And in fact, I did bump this just before, and there are some really fine droplets of wax in there now, but they'll congeal with the bigger lumps as time goes on. Now this glass bottle is actually quite hot now. It's almost hot to touch, and it's sitting on top of this also spun aluminium base here with a light fitting inside it. So I'm going to take this off here without burning myself. Just going to grab it by that cap there. And you can see that there's a heat lamp in the bottom of that aluminium spun fixture. Now, when I decided, let me turn this off. Now, when I had decided I was going to replace this part here with a casting, I thought about it for a while and I realised that I might upset the very delicate balance between the heat at the bottom of the lamp and the top of the lamp if I had something here which was a heavy wall, like a thick aluminium casting. So I've decided to retain this part here and just replace this conical base here. So I've done a 3D print of what that might look like, and I'll go and grab it. Now this is just a very rough draft of what this cast aluminium base will look like. So there's a sort of a parabolic rocket nozzle in the center here with three fins, and I've decided I'm going to take this conical section off the bottom of this heat lamp and throw that away. It's just held on with a single hex nut, and the top section of the lamp will sit on top of that three finned base. Now, this is just a prototype, and I've had to change this a little bit so that we can easily cast this in a sand mold. Now, it's an awkward thing to cast. You need to have draft angle on these fins so that you can withdraw it from the mould. It's actually going to be moulded that way, and it's got to be withdrawn from the sand mould, pulling it upwards. And that means that each of these fins here needs to have draft, meaning that this section of the fin needs to be much thinner than the top section. And also, I can't have any undercuts like I have there at the moment with this section here. That's going to make it very awkward to use as a pattern. So I redesigned this and it's printing now. I'm printing it in PLA, which normally I wouldn't do, but I've got some there. I just thought I'd give it a go. This one is actually PETG, and I printed this in 0.3mm layers, and it came out quite rough. That's why I'm not going to use it. But like I say, have modified it. Let's have a look at what we'll be using for the pattern. Oh my God, I think I need to look at my retract settings. I just removed all the stringing off this 3D print. It was pretty excessive. I don't know what went wrong there. I think I need to look at my print settings. But this is now the actual pattern for the sand mould to cast this part. This one was just a draft. So a few changes I've made. The first one being that I put a spigot on top of the rocket nozzle itself. And I can grab that in a 3-jaw chuck and spin it in the lathe so I can drill a hole up through the bottom of the nozzle, and that will form a hole for the cable to go up to the light fitting. Now this spigot here, this will take a piece of copper tube when we ram up the sand mould, and that will form the riser for the actual sand mould and the casting. But it also gives me an opportunity to grab that in a 3-jaw chuck if I can find one to fit inside the legs there, and then I can, if I need to, I can do some clean up on the surface here. The other change is that these fins now taper all the way from the foot here to the very top point. So it's actually a continuous taper all the way up there, so that when I go to extract this from the mould, I can pull it straight up and it should release. The other change I've made is I brought the surface of the nozzle all the way to the junction between the leg and the outside surface of the nozzle here. So this one's a lot easier to work with when we go to ram up the mould. Now, just so you know, this particular mould that I need to make involves coping down. So that means we've got to remove a lot of sand down to this surface on the curve of the fin. I've never tried it before. In theory, it's just a matter of just scooping away the sand till you expose that edge there. But when you go to ram up the coat, which is the top box in the mould, it means you've got this great big sort of lump of sand hanging down underneath it, and there's a chance it will just break off. But yeah, I like to live dangerously. Let's give it a go. Before I can use this as a pattern, I need to sand this all over, and I'm using one of these Sear sanding sponges for this. When I've got all of the imperfections that protrude above the surface, when they're gone, I will then spray that with an automotive spray putty. Now that will fill in the voids, the little troughs below the surface, sand that back, and then I'll paint it with an automotive top coat, and that will give us a nice smooth, hard, shiny finish that will extract from the sand mould quite easily. Any of these little layer lines here are likely to trap sand grains and pull them out as you withdraw the pattern. So you really got to get this as glossy and shiny as you can. This is the product that I'll be using for the first coat on the pattern. It's quick drying, it builds up very thickly, and it's really easy to sand back when you're done. Okay, I'll let that dry and sand that back, and then we'll give it maybe 2 or 3 more coats, and that will fill all of the texture in that pattern. And then the top coat is really just to give it a shiny finish. I've just been sanding that back with a grey sanding sponge. That's a fine one, 3M. And I'll follow that up with a grey Scotch-Brite. And here's, yeah, there it is there. That one's been done. And it starts to get a bit of a shine to it. And just on the edge, you can see the layer lines starting to be exposed as you cut back into the grey PLA. So when it's like that, it's silky smooth and it's ready for the top coat. Got a lot more sanding to do, so I'll do that and then we'll come back and give it the top coat to finish. I'll let that coat go off a little bit, and then I'll follow up with a heavier coat. We don't need a lot of paint on at this point, it's really just to seal off the spray putty that we've already got on there. Okay, I think that's good. Just going to let that cure now. So this process that I'm using here is called coping down, and it's a way of working with patterns that are otherwise impossible to extract from the sand mold. So if I can find the legs and follow the curvature of the leg down to the center, that will expose the pattern and allow it to be removed. Okay. There's one of the legs, so now I know how to follow that up to find the foot, and I'll have a rough idea of where the other two legs are. Okay, I'm going to tip this on its side and clean it all out, and then I'll show you what I've got before we put the cope on top. Well, I've done my best to find the parting line. Now there is a radius on the inside edge of that leg there, so you've got to get past that, and I've sort of been around, firmed up all of the sand on the actual joint line. I think I'm going to try to just wrap this a little bit loose before I put the cope on top. Alright, now, just so you know, I've got very little confidence this first one's going to work. There's so much to go wrong. The main thing now is that when I put the cope on top and fill it with sand, there's going to be this great big lump of sand down below the joint line, the actual line between the cope and the drag. When I pull the cope off, there's every chance that big lump of sand will just break off. It'll shear off at this line here, which is the level line. But I don't know, might get lucky. Right, sort of partly expected that. I think what happened was I left the two halves of the mould assembled and I went and had lunch. And I think what has happened is the moisture in the sand, which is a bit damp, has gone through the parting powder and bonded the two halves together. What I may have to try next time is putting some screws through from this section here up into the cope to try and retain this part in the cope. And yeah, I'll give it another go. But that's the pain of doing metal casting at home. Okay, so next day I've had a chance to think this over and I'm going to try out a fairly radical solution to this problem. I don't think it's worth trying to recreate what I did yesterday. So I've kept the drag and I've taken out all of the sand that broke off in there. I've exposed the pattern again. I've wrapped the pattern loose and now I'm going to make a sand and epoxy core. So I'm just going to do it. I'll talk about it as I go and may or may not work. Let's find out. So the first step in this process was to put 2 layers of plastic food wrap into that cavity, and then I can pour in just regular dry fine sand and fill up that cavity, and that gives me a way of actually weighing the volume of sand that needs to be mixed in order to go back into that cavity. So lift that out and we're going to weigh that. Works out to 1.72 kilos of dry sand. And I'm going to mix that with a 5-to-1 West System epoxy. So I weighed out, roughly 172 grams. Didn't work out exactly that, but it's close to it. And then we can start mixing that in with that dry sand. Now I didn't actually use the full 10% of that epoxy. It's really just a case of adding the epoxy and then mixing it and just checking the consistency. You want it to look like green sand. It should sort of hold together, but it shouldn't be sort of runny with resin. So once I had that thoroughly mixed, it was then back to the mold. I put a single layer of food wrap into that cavity, and then I'm going to push the steel former, which will form the riser, over the top of the pattern. And I've coated the outside of that steel tube liberally in beeswax. So once that's all in place, try and smooth the wrap out as best you can, and then you start filling the cavity with that sand and epoxy mix, just using whatever tools you can find to sort of ram that down and try and fill up the cavity completely. There will be some wrinkles in the food wrap, but I don't think that's going to be an issue. And when we've got it nearly full, we start to pack it down all the way around and start to level out the top surface as best you can with whatever tools you've got. Now once that's all been roughly level, I went around, packed it down one more time, and then I'm just driving 2 wood screws into there to form sort of handles so I can pull that form out later. Alright, now it's a bold experiment, alright? I'm going to let this set up overnight, and then tomorrow I can remove this plastic film, sort of cut around, try and tidy up the edge. Doesn't really matter if it's not dead flat, and doesn't need to have really neat edges. It's just to fill that void. Over here I've got a key, so I know how to put it back and get it aligned correctly, and then we just make up a regular coat on top of that, and hopefully it works. We'll see. Okay, so next day, that's set up really well. It's quite hard. You can see from this material here, it's going to hold together really well. So I'm going to clean up the outside of this plastic wrap here, and I'll ram up the cope and remove that, and then we'll get this piece out, and we can cut all the gates and all that sort of stuff. So this piece of steel pipe is loose. I'll leave that in there for now. I'll just remove the screws. I can drive them back in again later. Alright, so this little cutout here is the key, and on the core you can see the same part, that little projection there will fit back into that key. So I'm going to remove the plastic food wrap off the core, and then we've got to get the pattern out, and then I'll run a gate through from this little hole here, which is where the sprue goes down. We'll run that gate through the end of that leg there. Just heard a little pop then. Alright, that's looking really good in there. It's super clean, very smooth. So I'm just going to create this little gate here, and then we can put everything back together, I hope. Alright, so that's sort of fitting in there nice and snugly now. I'll remove these screws, we'll put the coat back on, and then we can get some metal in this. Now of course, having gone to all this trouble, there's still a chance that this won't fill properly. And it's very cold today, the mould is going to be cold, and then we're pouring hot metal in there. Now it's likely that it will freeze part way up these legs here, so it's going to pour down this leg first, fill the bottom, and then it's going to come back up and fill the other two legs. And it's very thin, so I'm going to have to heat the metal up a bit more than I would normally do, but I think then we can get away with it. I think that went really well. I can see the mould was filling up consistently, came all the way up to the top of the riser, but now it's just a waiting game. You know what? I think it's worked. Yeah, I sort of expected I'd have to do it twice. Oh man! Oh, you're kidding me. Well, that celebration was short-lived, wasn't it? So it didn't quite fill up to form that foot there. Bummer. You know what though? I think I can save it. Yes, I can save it. So we're just going to have to modify this foot and put some landing pads on it. I think that's the best way, because man, I don't want to do that again. So yeah, we got like 98% there. Never mind. I'll get this cleaned up and I'll show you on the bench. Well, I got it all apart. I didn't really foresee how hard it was going to be to get this core off the casting when it was done. and I tried using a blunt hacksaw and didn't get very far. And there was a danger if you tried to smash it up that you might bend one of these very narrow fins. So in the end I just cut off the top part of the riser and I was able to just wriggle this out. So the core has done its job. It's formed up the back of these fins, or the underside of those fins there, so I'm quite happy with that. And I've got a decent chunk of material I can grip onto in the lathe to do the top section, get that machined. Then I can flip it around and machine off that section of the riser. Now the downside is that I ended up losing the points of two of the fins. So this one and this one. This was the one where the gate was, and that's of course fully formed. I got metal all the way to the top of that, but I probably lost about maybe 8mm off the bottom of that fin. Same with that one, maybe a bit less. But you know what? It's probably a blessing in disguise because now I've got the opportunity to add some rocket boosters onto these fins, or some landing pads like big discs, and I could also just simply cut it off short, but I think I'm going to try and add a bit of bling to the bottom of those fins there. But what I need to do now is get all this cleaned up, get all the flash off it, and begin the process of machining the top and bottom of the rocket nozzle itself. And unfortunately lost a little bit of material out of the top of this fin here. Probably some sand had fallen down into the cavity, but I can reshape that and polish that up. I think it's going to be okay. So I'll get busy now and start cleaning up all this material, and then we'll get over to the lathe and finish off the rocket nozzle. I've got this sitting in a 3-jaw chuck and I've trued it up as best I can. And you may be able to see here that this leg, which is where the metal went into the mould, is touching the face of the chuck. But if we come around to this one here, I can fit my finger in behind it. So that's the shortest one. And there's another one here that's probably about like 3mm short, but it's very rounded on the end. So what I'm going to do is I'm going to scribe off with an adjustable parallel against the face of the chuck, and then I can cut that material off all 3 legs to make them pretty much the same length. Scribe that one, and this one's going to have the most taken off. So you can see here this one has quite a lot of material to come off, around about 16mm, that one about 15, and this one only about 3 or 4. So I'm going to make up that difference in height with a set of 3 retro rockets. Now I'll show you on the 3D model what that's going to look like. And when you think about it, every rocket ship on every science fiction pulp novel ever had a set of landing pads or retro rockets on the base of the fins. So that's where I'm going with this, and I reckon it's going to work. You can see it, all 3 of those feet now are sitting against the face of the chuck, and what I need to do now is clean up this little spigot, make it parallel, and I'll center drill it, and then I've got to flip it around and try to do the other end of the rocket nozzle. Okay, I'm going to saw off most of the stock from the other end now, and this is the only way I'm going to be able to grip it. Okay, I just had a bit of an afterthought here. I want to try to clean off the tops, or the points from the tops of these fins here. Now this one here was badly eroded when it came out of the sand mould. So it's sort of better to do it now while I've got something decent to hang on to, and then they'll all be the same. Then I'll reshape the top of those fins later. Okay, I think I'll stop there. I've got mostly solid metal right in the very center where the top of the curve will be, and of course I've got a reference point then for all of the others. Okay, this looks super scary, and it is, and what I've done here is I've put an ER40 collet chuck in the spindle and I'm gripping onto that spigot with the collet. Now I've got everything tightened up. I've got a long boring bar set up with a high-speed steel tool bit, which is very sharp. And what I need to do here is to face off the end of this nozzle. Now you've got to be aware of what you're doing at all times. I'm going to do a bit of this on camera, but then I'll turn the camera off because I've got to concentrate. And if it's one false move, it's all going to end in tears. And there's no repairing it. If I break it, I'm going to have to start right back from scratch. So let's do a little bit, and then I'll show you at the end if I make it. Okay, that's cleaning up okay. What I'll do now is I'll center drill and then put the tapping size drill in for the 10x1 thread, and then I don't have to go all the way to the center with the boring bar. Okay, I'm going to quit while I'm ahead. That's scary. There's a very tenuous grip with that collet there, and yeah, if I try and go any deeper, it's not going to achieve anything. I'm not going to really see up inside there anyway. So I'm going to put the thread in the bottom section here now, so I can flip it around and hold it on a threaded mandrel, and I think that's probably enough for today's video, and we might wind up there. As you can see, I've gone a little way towards getting a reasonable sort of surface finish on this casting now. So I did about 2 hours work yesterday. I started with a Dremel drum sander with an abrasive drum, and it was really good for doing these long edges and getting those sort of uniform, but it didn't really work on these big flat surfaces. So then I went to a pneumatic right angle die grinder with a surface conditioning disc, a fairly coarse one. Now that took off all of the cast surface texture, and it started to sort of flatten out that surface as well, but it was really gouging the material. I went to a Roll-Lock Scotch-Brite disc, and although that brought up a bit of a shine, it really wasn't removing the underlying scratches. In the end, I found the best tool was a fine multi-master oscillating sander. I used a 180 grit disc on that, and you could really hold that flat on that surface and work it backwards and forwards, and I could see the marks were disappearing, and I could see it was starting to form a truly flat surface. So I was also able to use that on the circular surface of the rocket nozzle, and I also had a go at buffing one of those surfaces there. Now, although that looks pretty good through the camera there, if you get up close to it, there are lots and lots of scratches and score marks and swirl marks and so on. So I am still evaluating whether it's worth going to that much trouble with this job. I can just bead blast this, and that will hide all the imperfections and it will leave it with that sort of pearly iridescent sort of finish, and I think that would work okay. But with these parts that came with the original lamp, I will put these in the lathe and sand off that sort of powder coat finish on it's there, and they will polish up to a mirror finish. I've already had a go at that one, and I think that's going to come up okay, and that will leave a nice sort of contrast between the original lamp parts and the cast base. Now I'm going to finish up the video now. It's sort of run out of time, but I'll ask you to come back and watch the next episode, and we will do all of the finishing on the parts. I will make the little retro rocket feet to go on the bottom of the fins, and we'll put it all together and see how it looks. And yeah, I think it's going to be a fun project. I'm glad I got this casting done. That was a bit of a bit of a nightmare really. I didn't think it was going to work at all. So come back next time, we'll look at the lava lamp finished, and yeah, it's going to look really atomic age. Okay, it's Prezzo signing out for now. See you on the next video. Cheers.